One of the great mysteries of nature is that gravity is a force that is much weaker than all other known forces, such as electricity or magnetism. To give you a quantitative idea of this, consider a very simple experiment where I'm lifting now my hand. In lifting my hand, the electrical forces in my body are able to overwhelm the gravitational attraction of the whole big planet Earth, which is pulling down on me gravitationally. So the fact that the electrical forces in my small hand can overcome the gravity of the whole Earth is a measure of how much weaker gravity is than electricity. And so that is a major problem in physics. It's called the hierarchy problem, the hierarchy of the forces, gravity and electricity. And it's one of the major challenges of our time to explain why I'm able to lift my hand. And it has given rise to many theoretical ideas that attempt to explain this. One of them is that gravity spreads itself thin by spreading inside extra spatial dimensions, or over and above the usual 3 dimensions that we know about: height, depth, and width.
Trying to understand a book like Lisa Randall's Warped Passages, which tries to describe whether there could be extra dimensions in space-time and how to visualize that. It's not easy for any of us to wrap our minds around that.
So having extra dimensions makes gravity weak because gravity spreads into them, whereas electricity, on the other hand, does not spread into the extra dimensions. It stays within our 3-dimensional world. So that gave rise to the theory of large extra dimensions, try to explain the weakness of gravity. If you want an analogy, the analogy is a river that moves in 1 dimension can maintain its strength, but the moment it spreads into many tributaries, it loses its strength. In the same way, gravity loses its strength by spreading inside extra dimensions.
It appears that gravity has something to do with space and time. Einstein's general relativity gives a description of gravity in which massive objects, or actually anything that has energy, warps space and time, or I should say space-time. Space and time are inextricably linked. It's not like there's one clock running for the whole universe somewhere. Your clock depends on where you are in space. That's the fundamental nature of space and time. And if you're in a different reference frame, clocks are running at a different rate, okay? For you, if you're moving at high velocity. And that's the fundamental result from relativity that Einstein gave us. But the fact that energy can warp space and time and cause the motion of other bodies to move along lines which depend on the presence of this energy, that's really profound. It really shows that the nature of gravity is linked tightly to space and time, whereas the other 3 forces, electromagnetism and so forth, they obey relativity, but they don't appear to be so tightly linked to space-time itself.
What causes mass is something called the Higgs field, after a physicist, Peter Higgs. And back in 1964, he and several others, to be quite honest, wrote down a theory that says that the universe is filled up with some kind of field. It's a little bit like an electromagnetic field that we don't really sense. It's called the Higgs field. And the reason things have mass is that the various particles of which matter is made latch on to this Higgs field with different degrees of strength. Heavy particles really latch on to this field really strongly, and therefore when you push on them, they don't, it's hard to dislodge them. Light particles like the electron don't latch onto this field, this all-pervasive universal field. They don't latch on, electrons don't latch on as strongly.